So you've probably wondered how an AI like ChatGPT actually works, right? Well, its origin story, the real beginning, it all starts right here. We're going to take a look at a 2017 research paper from Google that had this deceptively simple title, but it completely changed everything we thought we knew about artificial intelligence.
But before we dive into the paper itself, let's just start with a really basic question. How does a machine go from just seeing a bunch of words on a screen to actually understanding what they mean? The context, the relationships, all of it. For years, this was the central problem that had AI researchers totally stumped. You see, before this paper dropped, the whole field of AI language processing was stuck. It had this huge bottleneck. The models were getting a little bit better, sure, but they were all stuck reading sentences pretty much the same way we do, one word at a time. And that one simple fact was holding everything back.
The big technology at the time was something called a recurrent neural network, or an RNN for short. And the easiest way to picture an RNN is that it reads just like you or I would. It starts at the first word, goes to the second, then the third, all in order. For a really long time, this just seemed like the most logical way to do it.
But that one-word-at-a-time approach had two gigantic problems. First off, it was just slow. I mean, you literally couldn't process the 10th word until you'd already processed the 9 before it. That means you couldn't take advantage of modern computers to do things in parallel. But even worse, it had a terrible memory. By the time the model got to the end of a long paragraph, it had basically forgotten what it read at the beginning. It couldn't connect a pronoun at the end of a sentence to the person it was talking about at the start, a problem that researchers call long-range dependencies. It was a huge roadblock.
And that brings us to June 2017. A team at Google Brain published a paper that didn't just suggest a small fix. No, it proposed a completely different way of thinking. They didn't want to just improve the old method. They basically wanted to throw the whole thing in the trash.
And they weren't exactly subtle about it either. This quote from the paper's abstract says it all. The key phrases to notice are solely on attention mechanisms and dispensing with recurrence entirely. They were announcing a brand new model that called it the transformer that would completely ditch that slow, one-word-at-a-time process.
So what did they replace it with? This beautiful idea called self-attention. Instead of reading in a straight line, the model could suddenly just look at the entire sentence, all at once. Instantly, it could figure out how every single word relates to every other word in the sentence, creating this incredibly rich map of context in a split second.
So seeing the whole picture at once, that was the breakthrough. But how does that actually work? Let's take a quick look under the hood at this new transformer architecture. This visual is straight from the paper, and it shows self-attention perfectly. The model's trying to figure out what the word "it's" refers to. By looking at the whole sentence at once, it immediately draws a really strong connection back to the law. An old RNN model would have almost certainly forgotten about the law by the time it got all the way to "it's." Problem solved.
Okay, and here it is. The famous, and yeah, kind of famously complicated, diagram of the transformer. Don't worry about all the boxes. The main idea is actually pretty simple. The stuff on the left, the encoder, its job is to read and understand the sentence. And the stuff on the right, the decoder, its job is to take that understanding and generate a response. All the real magic happens in those blocks called multi-head attention.
And this is just so brilliant. To make the attention mechanism super powerful, they didn't just use one. They used something they called multi-head attention. In their model, they used 8 of these heads all running in parallel. The best way to think about it is like looking at a sentence with 8 different pairs of glasses on at the same time. One pair might be looking for grammar, another is figuring out who he or she is, and another is just getting the general vibe. It lets the model capture all these different kinds of relationships all at once.
Now, this table, this shows the mathematical magic behind it all. Just look at the max path length column. For the old recurrent models to connect the first word of a sentence to the last word, it took n steps. That just means the longer the sentence, the longer the path. But with self-attention, the path is always one. Every single word is directly connected to every other word, instantly. This one change was a total revolution in efficiency.
Okay, so this all sounds great in theory, but here's the billion-dollar question. Did it actually work? Let's see how this newfangled architecture did when they really put it to the test.
So they measured its performance on machine translation using the standard metric called the BLUE score. You can just think of it as a grade for how good the translation is. And the transformer, it didn't just do well. It set a brand new state-of-the-art record for English to German translation with a score of 28.4.
And as you can see right here, it didn't just beat the best models from Google and Facebook, it beat them by over 2 full points, which is a massive leap. But, and this is the real kicker, look at the training cost column. Those huge numbers are basically how much computer power it takes to train the model. The transformers number is way, way smaller, so it wasn't just more accurate, it was dramatically cheaper and faster to train.
I mean, the paper's conclusion says it all. The transformer wasn't some tiny incremental improvement. It fundamentally solved the speed and efficiency problems while also delivering a huge boost in quality. This was the breakthrough that everybody in the field had been waiting for.
And the impact of this paper went so far beyond just setting one new record. This thing didn't just introduce a new model, it gave the world an entirely new blueprint for how to build language AI from the ground up.
This was the fundamental shift, right here. AI went from this linear, one-by-one process that was slow and super forgetful to a parallel, all-at-once system that was incredibly fast and deeply aware of context.
So why does this one paper from 2017 matter so much today? Well, because the transformer architecture became the blueprint for pretty much every major AI that came after it. You know ChatGPT? The T in GPT literally stands for transformer. This paper isn't just a piece of history. It's the direct ancestor of the generative AI that is reshaping our entire world as we speak.
And that really just leaves us with one final thought. The paper was titled, "Attention is All You Need." Back in 2017, that was a pretty wild claim, but it turned out to be true. And that idea now powers our world. So the question we should all be asking is, what's next? What's the next big, simple idea that's going to feel just as revolutionary? What's going to be the next attention?